So I'd like to just finish up this second part right here today and get through these two examples and see if there's any questions on 6.1. Got a short quick quiz, short practice for you. I think you'll handle this just fine. So how about a volunteer to read number 6 for me? Volunteer to read 6 for me. Thanks, John.
Example 6, right?
Yep, exactly, yep.
An exponential function g models a relationship which the dependent variable is multiplied by 2.5 for every 1 unit and the independent variable x increases. Graph g times 0 equals 4. Compare to fx equals 4 times 2 to the x power over the interval x equals 0 to x equals 2.
Okay, this sounds like a tough problem. All right. So right here, guys, we're going to say that my variable is multiplied by what right here every single time? 2.5. And right here they tell you for that g of 0 is equal to what value, guys? 4. All right. Anytime they give you g of 0, f of 0, anything like this, g of 0 always is going to indicate a starting value for exponential functions. So in this case, what was g of 0 equal to? 4. So this is basically saying when you punch that first function in, the starting value for that first function is what number? 4. Okay? So what they're really asking you guys to do here is this. They're saying, hey, you have a function, g of x, that starts at 4. And then it's multiplied by what value every time, guys? So the common factor is 2.5. What they're saying is take this 4 times 2.5, and since it's an exponential, I need to put the x out here. They're saying take that function right there, and then they want you to graph it, but compare it to what function here, guys? What do they want you to compare it to? F of x, which is what? 4 times 2 to the x. Now I want to show you some stuff here about decimals. They ask you to compare it over the interval from 0 to 2. Okay, 0 to 2. So I want to get good at being able to help you with decimals, and I want you to be comfortable with what you're doing in here. So here's what we're going to do. I want you guys to jump into decimals real quickly. If you haven't gotten your Chromebooks out, that's fine. You can watch what I do up here, but if you feel more comfortable getting your Chromebooks out and typing this in, by all means, go ahead. I'm going to show you some ways to change the windows on here in terms of what they're asking. And I want to make darn sure that you understand. I think we kind of said on Thursday that decimals is kind of a savior for this section, isn't it? Okay. Yeah, you said you were close to, did you use decimals a lot on your assignment or not? Didn't have to too much? All right. Well, let's take a look at this, kiddos. What was the first function that we wrote for example 6? First function we wrote. What value are we starting with? 4. Okay, so take 4 and then, I guess for lack of a better term, exponentiate that value by 2.5. And this is going to be to the x power. Okay, now guys, here's what I want to tell you. They said do that on a window from 0 up to what? X equals 0 up to what? What do they say on the very end of that? For x equals 0 to 2. Okay, in your decimals right here, here's what I want to tell you. Do you guys, if you click on this settings wrench up here, go ahead and click that up there if you're into decimals. Do you see right here how it says x-axis right here? They want you to go ahead and compare that from 0 to 2. Basically, they want the smallest x value right here to be what value? Well, 0. So we'll put a 0 in there. And then I'm going to call this value right here 2. All right, from 0 to 2. And I'm going to go ahead and change my y values here. I'll just change the y values, just plug something in so we can see something. I'll go from 0 to, oh, I don't know, how about 25? All right. Are you guys okay with what I've put in there? You understand how I changed the x's from 0 to 2 here like they had suggested? Everybody okay with that? Okay, now I made a mistake up here. This should be an exponent, shouldn't it? Right up here and not a linear value of x. So I need to go back and change this. Okay, do you guys see this line curving a bit here now? From 0 up to 2?
Do you put the A to the end?
What's that one more time?
How do you get the X up there?
Okay, was there an A to the B button in there?
Yeah.
See where it's right right by A squared? Put that A to the B and then put X in there, and that's how you get your exponential there.
Okay.
Are you okay with that? Okay, and then they said compare that to the other function, which was it 4 times just 2 to the x? Is that what they had in that part?
Yeah.
All right, so 4 times 2 to the x. I'm going to write this in here quickly. Oops. Need to get my keyboard here. So 4 times 2 to the x. And I want us to compare this. It's 2. All right, I'll raise my power to the x. All right. What I'm really getting at is the following, guys. I really want you to understand what's going on here from 0 to 2. The blue graph, that's that starting value of 4 increasing by 2.5. And this is the graph 4, and it's increasing by a common factor of 2 for each change. And I shouldn't say increasing, it's doubling by a factor of 2 each time you move over on the x-axis. Guys, what do you notice right here? This is like the point 0, comma. Well, let me just click on that point. On the x-axis, this point is 0, comma what? 4. What's the starting value for both of these exponential functions right here? What's the starting value? 4. Okay, they both start at 4. Now, guys, you all like money, right? And as time increases or moves from the left to the right, if you have money invested somewhere, which graph would you invest your money with, the blue one or the green one? If this is my time factor down here as time goes on, and this is the amount of money you have left on the vertical axis right here, which company are you going to invest with, the blue one or the green one? If you have a certain amount of money to start with, let's say maybe $4,000. Why the blue one, Anthony? Yeah, it increases faster, right? It's increasing faster. So notice this right here, guys. The only thing that's different about these two functions right here is my change factor right here. Which one has the higher value, the blue graph or the green graph? The 2.5 or the 5. Which one has a higher change factor, the blue one or the green one? The blue one. So I could say, hey, the higher the change factor here, the quicker something is going to grow. All right? Here you're just doubling each time. Here you're multiplying by 2.5. So it makes sense that if you multiply with a larger number, isn't stuff going to grow up faster for you? All right, so here's what I want you to understand is compare these graphs, and I'll show you what to write in number 6. First thing I identify is they both start in the same spot, right? They both have the same A value. They both have the starting value of 4. That's the same. The change factor, though, is different in each one. And it looks like the higher the change factor, the faster a graph is going to grow. Make sense? So that's what I want you to get out of the graph from this right here. Here's what I'm going to write down here. What do you notice about these two? Well, first of all, I'll put two things that we notice right here. They both start in the same spot. And that makes sense because for both of those, the starting value was 4. They both start in the same spot. The second thing we notice, though, is 4 times to the 2.5 to the x power increases or grows. I don't care what word you want to put in there. I'm going to say increases faster than the function 4 times 2 to the x. And if I didn't have a graph right here, why would I say that the first function increases faster than the second? What would be your argument right here? What values am I looking at to make that determination? Why am I able to say 4 times 2.5 to the x increases faster than 4 times 2 to the x? Why am I able to say that? 2.5 is a bigger change factor than 2. Excellent, McKenna. Excellent. Okay. So when you plug stuff in and compare them graphically, do you understand how to do that? That's my first question. My second question is, they give you some x values to look at in between here. Do you guys, are you all comfortable with going into decimals, clicking on this settings tool right up here, and changing the x values right here and here that they want you to have in there? Are we okay with that? Okay, so all that stuff is right in here up under your settings for you to get those graphs. Yes?
So you, to put in the x's, you just put like, you put 2 for the one.
Yep, because they wanted you to be between 0 and 2. So the first value on the left, you plug in 0, and then the right value is 2. This is saying you're between 0 and 2 when we looked at compound inequalities before. Make sense? Okay. And then the y values, just kind of guess on y values so you've got at least a good picture. You might have to change stuff a bit. You know, you might have to guess on the y's a little bit to see a good picture, but the x's they should always give you if they want you to look within a certain window. Okay? Make sense? And if you still aren't sure, you can still keep zooming out and looking at this graph. Okay? You still get the same effect. See that there, Taryn? I've zoomed out a couple times now. I've still got the same effect right there. I can still see, well, they start at the same spot. The blue one grows up faster than the green one. So even if you don't get those constraints in there that they give you, not the end of the world, all right? Make sense? Okay. Good questions. All right. Let's look at this last example, and then I'm going to get you some time to work on some things here today. Number 6, good stuff. All right, so here we go with number 7. 7 is very similar to what we discussed on the front-loading problem from Thursday about all the bacteria that would still be in the fridge, even though Lysol kills 99.9% of germs, right? We said there was over 17 billion germs in your refrigerator, even if it killed all of them. All right, in example 7, it says the graph represents bacterial population Y after X amount of days. And we're going to model this on decimals. So it says the population can be modeled by Y equals 3 times 3 to the X. So I'm going to punch that in. So let me go back to decimals. And I'm going to punch that in. Y equals 3 times 3 to the X. Oh, where am I? There it is. Y equals 3 times 3 to the X. This will be a graph of bacteria growing. Guys, how many bacteria did I start with? What's the starting value? 3. Okay, that's this first value out here. Can't really go wrong on this. What's your change factor, guys? 3 also, okay? So guys, X represents the number of days that go by, and if I say Y is equal to this mess right here, Y is how many bacteria are going to be in that certain spot. So guys, when they say right here, the population can be modeled by Y equals 3 times 3 to the X, find the population of the bacteria after 6 days. Well, guys, what did X represent right here? Days. So we're going to take this 6 and substitute it in for which variable? So we're going to say the number of bacteria after 6 days, which is Y, that's going to equal 3 times 3 to the 6th. Now I know we spent some time on Thursday saying, hey, let's make sure our keystrokes are correct. Would I do the 3 times 3 first or the 3 to the 6th power first? 3 to the 6th. So I'm going to do that. And again, some of you guys, if you're not sure how to do powers in your calculators, check with me today. I'll make sure that you know how to do that. But this will be 3, and then I hit the X to the Y value. And then my power of 6, that's that many. And then what do I have to times by now, guys? Times your starting value of 3 right here. How many bacteria are going to be present here in that population after 6 days now? What's the value here? 2,187. Okay. So this means that there are 2,187 bacteria present. After 6 days. Okay. 2,187 bacteria present after 6 days. Okay, so I know a few of you guys were gone Thursday, and by the way, girls that were gone Thursday, raise your hands again. Where are you at? Congratulations. Awesome. Good job. The part 1 of this lesson, girls, it's on YouTube. If you want to get into that and watch that and listen to that, that'd probably be good for you to get the parts of the notes down. Or if you want to get them from someone else, that's fine. But we are going to do a quick quiz, so you might need to talk to your table partner about how to do that stuff. So if you run into troubles, let me know. But I think you guys feel okay about this? Not the end of the world. Remember, A times B to the X. A is your starting value, B is your change factor. So here's what we're going to do.